Okay, the next part I want to focus on is speed versus time graphs. So you've probably seen some of these before. Just simple graphs showing the motion of an object. So what are these actually representing? So the V is speed and the T is time. So there's two lines on this one. We've got a steep gradient and we've got a less steep gradient. Now both of those lines are straight. What do you think they mean? Have a guess before I reveal. Okay, now for the moment you've been waiting for. We could say quick acceleration. Now, it's acceleration because the speed is increasing. Here's the speed on the y-axis. That's increasing, okay? And it's at a constant rate, all right? So the speed is going up, 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 up. That's acceleration, okay? And it's quick because the slope is quite steep. Now, this slope is less steep, but it's still increasing in speed over time. So that one is slow acceleration. How about this one? We've got starting up high in terms of the speed, and then over time it gets lower and lower and lower and lower and lower until it finally hits 0. Oh, quick cameo by my cat. So this one would be deceleration because the speed is decreasing over time. And that would eventually, that object would stop. It would be at rest. How about this one? We've got a flat line. So the speed is constant over time. Constant speed. There's no acceleration. We don't know how fast it's going because there's no units on this axis. We know that it's not 0 because it's not down the bottom. So we've got a constant speed there. Okay, so simple shapes that you want to try and remember. I'd like you to pause now and just record graphs similar to this just for your notes. Okay, so for the next section of the video, I just want to look at graphing motion and looking at a speed over time graph where you're calculating the acceleration based on the gradient. Okay, so here we've got a speed over time graph. So as we just looked at previously, section A would be acceleration because the object is increasing in speed over time. Then we've got a flat line here which would indicate constant speed, and then decreasing during section C, which would be deceleration. Now, what we can do here is we can use the actual units on the graph to calculate the acceleration. Okay, so I've just got a few things here. In this case, the x-axis is time. Now that's easy to read from the bottom, and the y-axis is speed. Now, to calculate the slope of a graph, that's also known as the gradient, you want the y-step divided by the x-step. Now an easy way to do that is rise over run. So calculate the vertical rise and then the horizontal run. We have to do this in 3 sections because you can only do this on a straight line. If it's not a straight line, unfortunately, you won't be able to calculate the average velocity or the average acceleration. Rise over run, the rise going up is speed and the run going across is run, which equates to time on the bottom here. Now, speed divided by time is actually how you calculate acceleration, change in speed over time. That's the formula, so that's why it works on this graph. What I've got here for section A, B, and C is basically a format in which we'll try to calculate the average speed. I'll go through section A, and then I'd like you to pause the video to try to do section B and section C yourself by using the graph. You can go back a few seconds on the video and pause it on there to have a look. So the time for section A, it's only really small up here, but I think I can still read it. Section A, the time is going from 0 to 4, so 4 seconds. The initial speed is where we start. So the initial speed there would be 0. The final speed is the end point. So the speed at the end is all the way up here. Okay? So that's 10. There you go, 10. So the change in speed is the final, subtract the initial. So 10 take 0, so that's going to be 10 meters per second. So the acceleration, you want the rise over the run. And we've just done that. The rise is the change in speed, so 0 to 10 is 10. And the run is how far along you go. So that would be 10 divided by 4. 10 divided by 4 is 2.5. So the acceleration from here to here is 2.5 meters per second, or 2.5 meters per second squared. Try to pause the video to calculate the rest. So I've just got the rest of the equations here, the working out. Compare that to what you got, and that's how you work out acceleration based on the gradient of a graph. Cool. So just something to point out here, negative acceleration is also referred to as deceleration. But negative acceleration means slowing down. It means the exact. Guys, thank you very much for watching the video, and I'll catch you later.